Today, we're going to add the liquid to our fantasy style health meter. Let's go! So, in the last few episodes, we've been building this health meter. It's a bit complex, so I broke it apart into several episodes, and today we're going to add the red liquid. The most valuable thing about this series of 20 videos so far is not necessarily the UI elements that we've been building like this health meter. It's a set of subgraph nodes that we've been building along the way. You can use these to build all kinds of different user interface elements and other 2D effects. These are building blocks or shortcuts that make it faster to achieve the results you want. If you haven't been following along with this series so far, I've put a link in the description for each of these nodes so you can find the one you need and then quickly jump to the video where I show you how to make it. So if I add one of these in the graph in today's video, you'll know where to find it. Alright, so last week we created this nice specular highlight here and these reflections around the edge of our glass sphere. And today, we're going to add the red liquid that drains when the player's health goes down. We're going to start out in Unity today, and then we'll switch over to Unreal and make the same thing in that engine as well. Alright, so to start out, we're going to come down here to the bottom of our graph, and we're going to add the histogram scan node. And this is a node that we made previously in the series, and like I said, there's a link down in the description to the video where you can find how we made this. What this node does is it takes a gradient, like if I add a linear gradient node, we can connect that up here, and it scans through that gradient. So let's add a slider, and I'll just temporarily show you what this looks like. So we'll connect our slider here to position, and now you can see it went black because we have our position set to 0. But as I slide the slider, you can see that the histogram scan scans through the gradient. So, and I can control the thickness of this line here that's at the border between black and white with a contrast value. In my case, I'm going to set my contrast value to 0.99, so there's a really tight line there. If I set it to 1, that line will be perfectly sharp. But I don't want that. I just want a slight bit of fuzziness right there on the edge. And now we can create a parameter. Instead of this slider, we can add a parameter here that allows us to control the player health, or whatever other game feature we're displaying with this meter. So let's go ahead and open up our Blackboard and our Graph Inspector. And we will add a new float parameter, and we'll call it health. And I think in this case, I'm just going to default it to 0.5. And we'll drag it in here, and we can connect it up to the position. So now, whatever I pass into this health parameter is going to be the height of our histogram scan. So we've made that parameter there, but I'm just going to leave the slider connected for now so that we can easily display what's going on as we work on the shader. Okay, the next thing that we need to do is colorize our scan, because right now this is just like a black and white mask. So let's add a new color here in our Blackboard. We'll add a color and call it liquid color. And we're going to default our liquid color to just bright red. And we'll bring in our liquid color parameter, and we'll multiply it by our histogram scan. So now, wherever the scan was white, it's going to be bright red, and where it was black, it's still going to be black. All right, and then the last thing that we need to do is multiply this value by the mask coming out of our sphere gradient here. So here's our mask. We'll bring that down and add a multiply. And what this is going to do is, right now, this gradient that we're creating is just square and linear, and we'll multiply it by our mask here so that we can create the liquid inside the crystal sphere. Okay, and now if we want to put this liquid inside our sphere that we've created up here, all we have to do is take the results of this multiply and plug it into our lerp node that we created last week. So I'm just going to drag this up and connect it right there. And all of a sudden, we have a crystal sphere filled with liquid. And I can grab this slider here. And as I slide the slider, the liquid fills up to the top or drains down to the bottom. So this is pretty cool, but you might be saying this liquid is kind of lackluster. It looks a little bit flat. It needs a little bit more life breathed into it. So that's what we're going to do next. We're going to make the liquid feel a little bit 3D and even translucent, as if the light is passing through it and brightening up the other side. So let's go ahead and get started on that. In order to make this liquid look like it's translucent, I'm going to grab the normal of the sphere gradient here, and we're going to flip the red and the green channel of the normal, so we're kind of inverting that normal. So I'm going to bring this down and create a flip node. And here's our flip. So here's our normal as it is, and we're going to flip the red and the green. So we're kind of creating like the normal that's inside out of the original. And I'm going to create two effects that make our liquid look 3D and translucent. The first effect is a bright spot on the opposite side from where the light is coming. So in order to do that, we're going to bring in our light direction and we're going to add it to our normal. And this is going to look kind of goofy for a minute, but this is very similar to the half angle that we created in last week's video. So I'm going to normalize the result here. And then we're going to do a dot product with the normal. So I'll connect up our dot product, connect it to the normal. And now you can see we've got this shading where it's bright down here in the lower region of our sphere and dark up here in the opposite region. I hope you can see that's why we inverted our normal here. We flipped the red and the green so that instead of the light coming from the upper left, now it looks like the light is coming from the lower right. And that's what we're using to make this feel like it's translucent. And now all we need to do is tune this a little bit so that we can tighten up our spot here. And the way that we're going to tune it is with a power node. So we'll raise it to a power. And in this case, I happen to know that what I want is raising it to a power of 24. So now you can see what we've got here is it looks like the light is coming from the upper left here and shining through the liquid and coming out the other side. And that's exactly the effect that we're going for. Okay, so we've got that effect. And now the other thing that we want to add is a little bit of rim lighting here on the upper left to show that the liquid is also being lit by the light source as it comes down from the upper left. So the way that we're going to do that is we're going to grab our light direction again, and we're going to use a dot product. So we'll do the dot product between the normal and the light. And you notice that because we flipped our normal, it's giving us shading coming from this angle instead of from the other angle. And now we're going to tune this just a little bit using a histogram scan node. So here's our histogram scan node, similar to what we did up here. And this allows us just to tune our gradient just a little bit. So we're going to pass the result of our dot product into our histogram scan node. And then we're going to set our position to a value of 1.1 to just push it a little bit more in that direction. And then we're going to set our contrast really low. We'll set it to something like 0.1. And now you can see I've got something that looks like the opposite of rim lighting. I've got it black on this side and everything else is white. So now all we have to do is take this and add a 1- to invert it. And now we've got a nice rim light happening on our sphere. Okay, so we've got our translucent light shining through the back of the liquid, and we've got our rim light lighting up the front of the liquid. And we need to combine these. So I'm just going to add a maximum node here. We'll find the maximum between our nice bright translucent spot and our rim lighting. And we end up with a cool mask that is the combination of our rim lighting and our translucency spot. Okay, so what are we going to do with this mask? We basically just need to combine it with our color. And so I'm going to take our liquid color here, and we're going to add a lerp. And wherever our mask is white, we're going to use our liquid color. And wherever it's black, you know, this is a little bit too dark here, so I think I'll give it a value of 0.1 just to brighten it up a little bit. Oh, and it looks like I made a mistake here. It's not 0.1 that I want, but 0.1 multiplied by our liquid color. So I need to take our liquid color here and multiply it by 0.1. So I'll do 0.1, 0.1, and 0.1, and then plug that into the A of our lerp color. So now you can see we've added this really cool element of depth to our liquid. We made it look like a round sphere instead of just flat like it is now. So here we've got flat liquid, and here we've got 3D liquid that actually looks translucent. So let's go ahead and plug in the results of our lerp. What we're going to do is, instead of passing in our liquid color here, we're going to pass in the shaded liquid there instead. So I'll take the results of our lerp and plug it into that multiply. And now you can see we've got this really cool looking red liquid, and we've tuned it so that it's inside our glass sphere, and we can change the level of the liquid. And if we come up here to the top of the effect where we've been working, we've got the liquid inside our crystal sphere, and we can drain the liquid or fill it. And it looks like it's translucent because of this brighter red area here, and also the light illuminating that rim lighting that we've got there on the upper left. All right, so we're making some great progress on our effect here. Let's go ahead and connect up our health amount to the position and just kind of clean up our graph a little bit here. And it looks like there are two effects that we have left to add. So we've created our sphere, we've created the reflections around the edges, a specular highlight, we've filled it with red liquid, but in order to make this liquid look a little bit more convincing, there are two more effects that we need to add. We need to make the liquid animate with waves, or make it slosh a little bit, and we need to make bubbles coming up from the bottom as if the liquid were carbonated or imbued with magical power or something like that. So in the next couple of weeks, we're going to both add the waves and also fill the liquid with animated bubbles. So I hope you tune in next week and the week after that for those. In the meantime, let's go ahead and switch over to Unreal, and I'll show you how to make this same effect there. All right, here we are in Unreal. And we've got our material set up just the way that we left it from last week. Last week we created this nice specular highlight here, and we created these reflections around the edge of our sphere. Today we're going to fill up our crystal sphere with liquid. So let's go ahead and come down here to the bottom of our graph, and we're going to add a histogram scan node. And what this node will allow us to do is create an effect that takes a linear gradient. In fact, let's go ahead and make a linear gradient node, and we'll plug in the V gradient of the linear gradient there. And let's go ahead and preview this node. So what you can see here from our linear gradient, we have a nice smooth gradient. We're using a V gradient, which is vertical, but the preview is showing the horizontal one. And if we plug that into our histogram scan, what you can see is that our histogram scan is going to tighten up our gradient depending on the value that we plug into contrast. So I'm just going to create a new static value here, and we'll give it a value of 99 and plug that into contrast, 0.99 I should say. And now you can see we've got a nice tight line here in our gradient between our black and our white. So our gradient starts out really broad, going all the way from the top to the bottom. But because we've plugged in the histogram scan, now we've tightened up the gradient so it's just right there in the middle. And we can also determine the position of this line between black and white. And that's what the position input is for on our histogram scan node. Now for the position, we're going to want to add a new function input. And we're going to call this one health, because the player's health is what drives this value. So as the player's health goes down, our line is going to go down here. And as the player's health goes up, it's going to go up. So we're going to set our function input to be a scalar. And I think for now, I'm just going to default this to like 0.9 so that our glass will be mostly full. So now you can see that we've got our the line in our gradient here right up at the top. And so this is where our health is going to be full right here. Okay, the next thing that we need to do is add a color. And so I'm going to add another input here. Function input, and we're going to make this one a color. It looks like we don't have a specific color data type, so I can just use a vector 3. And we're going to call this one liquid color. And I'm just going to default it to a color of bright red. So I'll give it a value of 1000. All right, so now we have our bright red color. And we just need to take the result of our histogram scan and multiply it by the color. So we'll just multiply the color in there. And then the last thing that we need to do is mask it, because if we preview this guy right here, now you can see we've just got a full screen full of color. And what we actually want is for the color to be inside the crystal. So I'm going to take the mask here from our sphere gradient node and bring it down. And we'll use that as a mask to multiply with the liquid that we created. So now you can see that we've got this nice round liquid, and the level of the liquid is controlled by our input health value, and the color of the liquid is controlled by our input liquid color value. Okay, so now all we need to do is take this result and plug it in here. We've got this lerp value where we're lerping between black and the value of our gradient around the edges. And instead of lerping between black, we can just take the value that we've calculated down here and plug it in. And now when we preview our end result, you can see we've got a nice crystal sphere with this red liquid filling it up. Really cool. All right. That's pretty good, but the liquid looks a little bit flat. It's got no lighting on it, and it's just a solid red color. And what we're going to want to do is change the liquid a little bit so that it looks translucent. So it's bright in some areas and darker in other areas. So we just kind of bring it to life a bit. There are two effects we're going to add, in fact. We're going to make the liquid look like it's translucent. So the light is coming from here, from the upper left, and that's why we have the specular highlight there. And we're going to make the light kind of come out the liquid on the other side. So we want to brighten up this area here, and then sort of darken everything else. And then the other element that we're going to add is a rim light here, to respond to the direct lighting. And so in order to create this sort of inverted lighting so that our liquid looks translucent, we need to do some changes to the normal. So here's our sphere gradient. Here's the normal coming out of there. And we want to invert it, but only the X and the Y. So let me show you what we're going to do. We're going to take our normal here, and we're going to multiply it by a vector 3. And we're going to give this a value of -1, -1, 1. And so basically what this is doing is it's negating the X component and the Y component, but then leaving the Z component as it is. And so we're basically creating like the inverse of the normal. So let's go ahead and bring this value down here. And there are the two effects that we want to add. We want to add the rim lighting, and we want to add a nice bright spot here that represents the translucent light that's coming out the other side of the liquid. Let's start with the translucent light. We're going to come up here and grab our light direction input. We'll just bring it down here. And this is going to be very similar to the specular highlight that we created last week. First, we're going to create the half angle between the light direction and the normal. And so to do that, I'm going to add these two vectors together. And then we're going to normalize the result. And then we're going to do a dot product between this normalize here, our normalized half angle, and our altered normal. So if we do a preview of this node here, now you can see we've got this really interesting result where the sphere is black up on this side where the light is coming from, and it's brighter down here on this side. So now to create the effect that we're looking for, we just need to take this gradient and tighten it up a little bit. And we can do that by adding a power node. So if I take the result here and raise it to about a power of 24, now you can see that we've isolated that nice hot spot to the lower right of our sphere, which is where the light is shining through the back side of the liquid. Okay, so we've got a really nice translucent hot spot for our liquid there. Now let's go ahead and create the rim lighting on the other side. So to create the rim lighting, we can take our normal here and do a dot product between our normal and our light direction. And now we're going to add another histogram scan node because we want to kind of tighten up what we're getting from this. In fact, let's go ahead and preview this. And you can see what we're getting here is a nice black area on the rim and a bright side over here. So if we plug this into our histogram scan node and then just tweak our values just a little bit, let's see. We want to set our position to a value of 1.1. So we'll just plug that in. And then we want to set our contrast really low. We're going to set our contrast to 0.1 and plug that in. And now let's take a look at the result of our histogram scan node. Right, so now you can see that we've got this black edge right around the edge of our sphere. And to turn this into rim lighting, all we need to do is invert it. And so we can just add a 1 minus node to give us the opposite. And now you can see we've got this cool looking rim lighting. Okay, so to combine these two, we're going to take this effect here, which is the translucent lighting, and this effect here, which is our rim lighting, and combine them together. So we just add a maximum node. So whichever is greater, the translucent lighting or the rim lighting. And if we take a look at this, now you can see that we've got the two effects combined together. And this is the mask that we can use to create our 3D looking liquid. So let's go ahead and add a lerp. And wherever the liquid is the brightest, so here's our mask, we'll plug that into the lerp alpha. Wherever the liquid is the brightest, we're going to use the straight up liquid color. And wherever it's dark, we're going to multiply the liquid color by a value of 0.1, just to kind of darken it down. So here's the dark value of the liquid and the bright value of the liquid. And we'll blend between those two using that mask that we just created. And we'll end up with something that looks like this. And it's pretty cool. Wow. Okay, so if we want to use this value now, instead of the flat value that we're using here, all we have to do is take the result of our lerp and plug that in. And now let's go ahead and preview the whole thing. All right, so you can see that our liquid has this nice highlight down here, this nice rim lighting up here, and it's a little bit darker in between. So pretty cool. We've got the liquid going. We've got it looking translucent. We've got a nice reflection highlight and a specular highlight. We do need to do a couple more things to the liquid though, and that's what we're going to do next week and the week after. We need to make the liquid animated so that the surface here, let me just change our health value here. Let's set our health just to 0.5 for now. So we want to animate this liquid edge so that it's creating some ripples or some waves. And the other thing that we want to do is add some bubbles that are rising from the bottom of the liquid so it feels like it's imbued with magical power or something like that. So that's what we're going to do in the next 2 weeks. So I hope you will come back and enjoy creating waves in our liquid and adding animated bubbles. All right, so that's our tutorial for today. You can change the health value to raise the liquid or drain the liquid. And we also created our nice translucency brightness here and some rim lighting on the upper left of the liquid. So pretty cool tutorial today. Come back next week to see how to add the animated ripples in the surface of the liquid. Have a great week, everybody.